And finally we come to awk. Awk is probably the granddaddy of all filters. The text processing that you can perform with awk covers, well, just about any text processing you could ever want to do. Awk actually stands for Aho, Weinberger and Kernighan, who are the three gentlemen that created it. It's not just a text processing tool, it's also a full-on programming language in its own right. It supports if statements, loops, functions, and just about every other major feature of a procedural programming language. It's an extremely powerful filter because of this, but it is also consequently probably the most difficult of all filters to master. I was once charged with a development project in awk, and the final program that I came up with was over 3,000 lines long. Now, I'm not going to go into the depth of awk required for such programs. I'm going to just give you the basics that you'd use in a conventional shell script. If I was to go into awk in its own right, we'd probably have another training course, another CD if you like. So its usage is fairly similar to sed as follows. You specify an action and then you specify the files that you want to perform the action on. As with sed and all the other filters, the files parameters are optional, and if you don't specify them, it takes its input from standard input, the keyboard, or another program. Differently to sed, however, the action that you specify is actually specified a little differently. It's a sequence of statements enclosed in curly brackets or parentheses. Each of them is separated from the next by a semicolon. For example, you take the who program and pipe it to awk, and notice that there is one parameter after awk, which is the one action that we want to perform. The action is enclosed in braces, new brackets, and all of that is enclosed in single quotes. Now, because it's enclosed in single quotes, things like the $1 and the $2 that you can see there are treated as special characters by the awk program. They're not treated as special characters by the shell. So similarly to sed, you should enclose all awk actions inside single quotes. So in order to understand what's happening here, we're obviously going to be printing something out. We're probably going to be printing out the words is on terminal at some point, but we've got this $1 and $2 and the commas to worry about. So in order to understand exactly what's going on here, why don't we have a look at the output of the who program in some more depth. So if we run who, we find that each line consists of a username, followed by some spaces or tabs, followed by a terminal, followed by some spaces or tabs, followed by a month, then a day, and then a time. Now, I was being pretty pedantic mentioning that things were being separated by spaces and tabs, but that is actually significant, especially when it comes to awk. So this is how we treat each one of these lines. Each one of these lines can be said to be broken up into a series of tokens, and each token is separated from the next by either a space or a tab or a series of spaces and or tabs. And so it's fair to say that on each line we have 5 tokens. One is the username, then the terminal, then the month, the day, and finally the time. Now these 5 tokens are actually numbered by awk. They're not numbered at the moment because we haven't involved awk in this equation yet. We've just used the who program, but if awk was to get involved, each line would be said to consist of $1, $2, $3, $4, and $5. So $2, of course, would be, in this case, the terminal, and $3 would be the month, and so on. So if we were to type in the command line that we just had a look at just a moment ago, and there it is, then we run that, and we get the output displayed slightly differently. $1, as you recall, was the username, and $2 was the terminal, in this case, for example, PTS38, PTS48, and so on. So the command line itself involves a print statement. So what print does is it takes a series of parameters. In this case, there are 3 parameters, and they're separated by commas, $1, and then the next one is just a text string, is on terminal, and then the third parameter is $2. And what print does is it prints out on the screen each of those 3 parameters separated by spaces. So it prints out $1 first, in other words the username, followed by a space, followed by the 3 words is on terminal, followed by another space, followed by the $2, which in this case will be the terminal. I hope you're beginning to see the pattern of how awk works. So to summarize that business about tokens, $1, $2, and $3, and so on are the tokens from each line of input, and by default tokens are separated by spaces and or tabs. Now it's actually possible, using the -F option to awk, to specify the characters used to separate tokens. For example, here is another awk line, and this time I'm using the -F colon. Now that designates the colon as being the token separator instead of spaces and tabs. If you think back to our course project, we're actually using the colon there to separate one field from the next. That's what the capital F stands for field separator. And if you've ever had a look in the file etc password, which is what we're dealing with here on this line, you'll find that it is also separated from one token to the next by a colon. Let's have a look at that. Here is etc password, and as you can see there's a bunch of fields on each line. There's the username, and then that little X is supposed to represent where the password goes, so that's 2, then the user number and the group, that's 4, then their name 5, then their login directory 6, and finally their shell 7. So there are 7 different parameters on the line, and each is separated from the next by a colon. So if we wanted to use awk to tokenize each line of the /etc/password file, we'd need to use the -F colon field separator is colon option to break it up into the various tokens. So once it's broken up that way, we can obviously print out $1, which would be the username, and then a space, and then home colon, and then a $6, which $6, as I recall, is the user's home directory. So let's have a look at that working in action. Here is a little file that I will actually put on the CD for you called parse password, which parses the password file in /etc, and it's a shell script, so let's run it like that, and as you can see there's quite a lot of output because we have a very big /etc/password file. Now I pressed Control-C there to stop it scrolling all day, but you can see that it's actually working. For each one, R. Ryan's home dir is /home3/R. Ryan, and so on. And that's all made possible by way of the field separator being specified as a colon.